All right, we're going to look at solving some rational equations, but when they relate to a word problem. And again, when you looked at systems of equations in Math 10C, the hardest part about those questions was setting up the actual equations. Solving them usually wasn't too bad. The same thing's going to happen here. So if we can't set up these problems, it's going to make it very difficult to solve them. So the first one we'll talk about is a distance, rate, and time problem. Kind of sounds like physics. But we can translate it into something we know how to do in math. So it says Jerome rows his boat 24 kilometers downstream and back to where he began. When the average speed of the current is 2 kilometers per hour, Jerome can complete that journey there and back in 9 hours. So what is Jerome's average rowing speed in still water? So the question gives us some stuff to work with. A chart is kind of helpful to organize your information here. Not totally required, but it would help to put some stuff down and keep it organized. So the distance, both downstream and upstream, we're going to basically go downstream to a certain point and back to where we started. So those distances are going to be the same. They're both going to be 24 kilometers. Okay, the time, we're going to need the speed in order to do this. So we're given a formula that says a speed is equal to a distance divided by a time. So kilometers per hour, meters per second, miles per minute, whatever the units are, you could do this. Now, for their average speed, there's two things we have to think about. The speed that Jerome's actually rowing his boat, plus the speed of the current. So rivers only flow one direction. They always go downstream from higher elevation to lower. So if you're going down the stream, you're traveling with the flow of the water. So you're going to have the speed of your boat plus the speed of the water. You're going to be going faster. Now, we don't know how fast he's rowing, so let's make that our variable. Essentially, that's what the question is asking us to look for, Jerome's average speed. Okay, now we have to add that 2 kilometers in because the current is pushing us. On the return trip, going upstream or going against the flow of water, those two forces are in opposite directions. So we're going to have to account for that change in direction, and we'll do it with a subtraction sign. Okay, essentially, we're going to be going slower on the way back. Now, time is given to us in this relationship. Now, that relationship is equal to speed. Let's rearrange it to make it equal to time. So if you switch things around, you're going to have time being equal to a distance divided by a speed. Now we have expressions for both of those, so we can translate them into an expression also. So downstream, that time is going to be 24 divided by x plus 2. There's our expression for time. Upstream, very much so the same, 24 divided by x minus 2. Okay, so I've got a couple expressions. So this is where the rational expression part comes in. I'm going to have a couple non-permissible values now. But we do have a way of figuring out how fast they're going to be traveling. Now, we were told the total trip, downstream and upstream, took 9 hours. So if we take the times for each leg of the trip, downstream and upstream, add them together, in total that should be 9 hours. So if we do our 24 over x plus 2, that's downstream, plus the 24 over x minus 2, that's upstream, in total, that trip takes 9 hours. And this is the equation we're going to solve. Okay, in order to do that, we've got to add together two different rational expressions, which means that we need to have common denominators. Now, we've got basically three things to worry about here. I've got the first fraction, the second one, and 9. Now, the 9's got a denominator of 1, which is helpful for us. So what we can do is we can take the entire equation that we came up with and multiply it by all the denominators. What that'll do for us is give us something that's common. Okay, so the first term gets its x plus 2's canceled out. So we're going to be left with 24x minus 2. Essentially, we're taking everything we're multiplying by and distributing it to every term. Okay, that's what's happening here. In our second fraction, we're going to have a 24 times x plus 2 equals to 9, x minus 2, x plus 2. Okay, now it turns into a Math 10 problem where you can distribute collect-like terms. Actually, I shouldn't say Math 10. Maybe it turns into a quadratics problem by then. Okay, so let's distribute and see what we end up with. So we're going to have 24x minus 48 plus 24x plus 48 equals 9x squared minus 4. Essentially, it's like a difference of squares. If we combine some terms, shrink that. If we combine some terms, we're going to have 48x on the left equals 9x squared minus 36 on the right. Okay, put everything on one side, and you'll see what I mean when I said this was a quadratics type question. So 0 is going to equal 9x squared minus 48x minus 36. Okay, as soon as you see something with a degree of 2, so a quadratic equal to 0, your first thought should be to try and factor this, because if you can factor it, you can find those zeros, and those will give you your two potential answers. So let's do a greatest common factor here of 3, and we're going to be left with a 3x squared minus 16x minus 12. That's going to be equal to 3, and then we can factor this. So I won't go through that process. But if you factor them using the method of decomposition, you're going to get 3x plus 2 as one factor, x minus 6 as the other. Now what you can do is take each of those factors and make them equal to 0 like we've done before. That means x could either be negative 2/3 or x could be equal to 6. Now we've got to take a look at a couple of those answers and actually analyze what they mean. Now x in the beginning when we defined things was a speed. I'm not really going to be looking for a negative speed. That would mean I'm going backwards. Okay, so I don't want to take that one. I do, however, like the other one. It's a positive number. It's not really a fraction, which, I mean, the speed could be. But here it's a nice round whole number. So that's going to be Jerome's speed. Okay, that'll be the value of x. So therefore, his speed in still water is 6 kilometers per hour. Okay, again, once that equation's set up, it's very similar to solving any other equation that we've done with rational expressions. Factoring we took care of in quadratics. It's just going to be the setup that might be a little tricky here. Okay, let's look at another one. Competing in an endurance race, Shannon cycled for 120 kilometers, swam for 12. Her average cycling speed was 8 times faster, so that'll be important, 8 times faster than her average swimming speed. Shannon took 9 hours to complete that race. Calculate her average swimming speed. So she's doing 2 different things in this race, and each of those are happening at different paces. Okay, so let's put in some information again into that chart based on what the question told us. So we know that they cycle for 120 kilometers. Okay, so there's our distance. They swim for 12 kilometers. Okay, so that's nice. Average cycling speed was 8 times faster than the swimming speed. Now again, we're asked to find that swimming speed, so that should be our variable. Okay, the cycling speed has a relationship to it, so it's basically telling us it should be 8 times whatever that speed was. So if my swimming speed was x, my cycling speed is 8 times that, so 8x. Again, we still have that relationship between speed, distance, and time. So speed is equal to a distance divided by time. That means when you rearrange that formula, time is equal to distance divided by speed. Very, very similar to the one before. Okay, so our time is going to be distance over speed and distance over speed. We are told again what the total to complete that race is. So again, very similar to the one we just did above. So 120 over 8x plus 12 over x in total, that should equal to 9. Okay, you could reduce the initial fraction, that 120 over 8x. You could make it lowest terms here if you'd like. Now what that would do for you is it would pretty much ensure that you've got common denominators. Since one of them is 8x, the other one is x. If you take 120 and divide them by 8, actually reducing that fraction, you're going to get 15 over x plus 12 over x, and that's going to be equal to 9. Okay, what you could do at this point is add those two fractions together on the left-hand side of equals, and you're going to get 27 over x that's equal to 9. Essentially what we've done is taken that problem, that situation, change it into a proportion, which you would have dealt with in junior high. A couple ways you could do it. Remember that 9 is just a number, so you could divide it by 1, and then you could cross multiply. So that would mean 27 is going to be equal to 9x. If you divide both sides by 9, 3 is going to be that value that we care about. Okay, so by doing that, this is now going to tell you that Shipman swimming speed is 3 kilometers per hour. Now this is an average, so I should actually say average swim speed here. So let's move this. Shannon's average swimming speed is 3 kilometers per hour. Okay, if you didn't make that simplification step where we did with that 15 over x, you could find the common denominators just like you normally would have done and go through the exact same process. You just get something that looks like a quadratic that you have to factor, but either method you're still going to get 3. Okay, let's look at one with it's a little bit different. So you've got a couple people doing some work together, and you want to figure out how fast one person can work alone. So this one says Kira mows a lawn in 40 minutes. Mark and Kira work together. They can mow the same lawn in 24 minutes. How long would it take Mark to do the same job by himself? Here, I'm not a big fan of the chart, so I'm going to put some information on the side. So we're going to say that for Kira, she can do one lawn in 40 minutes. Okay, so by writing this fraction, we're creating a relationship between the amount of work she can do in a certain amount of time. So we're creating a rate here. Now, if you want to write that a little separately, you could say it's 1 over 40 lawns per minute. Okay, just like we did the speed, it was kilometers per hour. They can do lawns per minute. That'll work also. Okay, so that's for Kira. For Mark, he could do one lawn in an amount of minutes we're not sure about. So you can say this is 1 over t lawns per minute, because we don't know how fast it's going to take him. That's what we're trying to find. Now the question does give us some information if they were to do this same job together. So we can write a fraction for that also. So if it's Kira and Mark, if they do the same job together, they can do that one lawn in 24 minutes, I believe it says. Yeah, 24 minutes. So that ratio is 1 over 24 lawns per minute. Now the reason why this is kind of nice, all the units here are the same. Every one of those fractions is lawns per minute, which means I'm actually able to add them and subtract them just like I would like terms. Now, the setup here is going to be important once again. If I do Kira plus Mark, that should give me the total, the rate that they do it together. Okay, I have expressions for each of those things. So for Kira, it's going to be 1 over 40. For Mark, it'll be 1 over t, and together, that should equal 1 over 24. Okay, each of those fractions are going into the place they need to. Now at this point, you do have that variable on the bottom, so we know Mark can't cut that lawn in 0 minutes. That's just not possible. Okay, so as long as my value is not 0, we're okay. Okay, so let's try to solve this. So what we could do is rearrange it. So let's subtract 1 over 40 on both sides. Okay, 1 over t is equal to 1/24 minus 1/40. So 1 over t, that will give you 1 over 60. Now, if you're wondering how to put that actually in your calculator, you can hit the brackets and put it in just like you see it. Now, for fractions on this graphing calculator, be very careful and use those brackets. Minus 1 over 40. Sometimes your calculator doesn't do exactly what you want. Okay, so you get a decimal here. If you press math, option 1 will take anything on that screen and turn it into a fraction in lowest terms if possible. So hit enter. Okay, Okay, that subtraction is going to give us 1 over 60, which also means that t is equal to 60 if you were to solve that. Okay, which is going to tell us, so therefore we figured out what t is. Now I know how long it takes Mark. Originally, when we defined this, we defined t as being the amount of time that it takes Mark to actually cut this lawn. So t, so therefore, Mark can cut the lawn in 60 minutes or 1 hour, however you prefer to write it. Okay, so that's how long he could it would take him to do the same job by himself. Okay, and again, it really is the setup here. Solving that isn't terribly difficult, but coming up with those expressions, that's going to be the tricky part here. Okay, that's going to be the most amount of work. Okay, a couple more that we'll talk about that end up being slightly different. So this one talks about a proportion underneath. So you've got antifreeze is what it's talking about. So antifreeze is added to water to make a solution that's used in automobiles. How much antifreeze must be added to 12 liters of water to make a solution that contains 40% antifreeze? Now, if this was a multiple choice question, one of the answers would probably be someone trying to find out what 40% of 12 is. So if I try to do 0.4 times 12, it would tell me that I get 4.8. But I can't actually do that. Okay, imagine that you've got a container that's, let's use an easier number here. Let's just use 10. Okay, so it's got 10 liters of water. Okay, if it has 10 liters of water in it, and I try to find out what 40% of 10 is, it would tell me that it's 4, right? 4 liters. Now, if I say that there's 4 liters of antifreeze in there, but if the solution is only 10 liters in total, that means 6 liters of it has to be water. Okay, so in total, I still have 10, but the proportion would be a little off if I just added in 4 liters. So if I add in 4 liters of antifreeze, then I've got 4 liters of antifreeze inside, but I've got actually 14 liters total liquid. Okay, and the percentage there wouldn't really work out for me. Okay, so 4 over 14, that'll give me 0.28, almost 30%. Won't give me the percentage I actually need. So let's translate this now into the numbers in our question. Okay, so now we can imagine that I've actually got that 12 liters of water like it says. If I add in with the 40%, which is 4.8 liters of antifreeze, then what I've got is 4.8 liters of antifreeze, but a total amount of liquid now of 12 plus 4.8. So my total amount of liquid is actually 16.8. That's the total. Okay, if I find that percentage, I need it to be 40%. Okay, if I actually just divide those two numbers, it would give me a ratio. And again, if I turn that into a percentage, I'm only seeing 29-ish% here. Okay, the solution isn't strong enough. So I've got to account for this a little differently. So this part I actually can't do. Okay, this is actually incorrect. Okay, so we've got to come up with another way here. Now, if I imagine the same scenario, I've got, I'm just going to shrink this one, and we'll draw a new situation. Okay, so here's my beaker. I have that original 12 liters of water, but let's add in X amount of antifreeze. Okay, if I add in some unknown value, I'm increasing the total also. Okay, so if I want to find the actual percentage of antifreeze I have now, I can take the amount I'm adding in and divide it by the total. In this case, 12 liters original of just the water, plus the increased amount of antifreeze. That ratio needs to give me 40%. Now, in doing that, I can find out what the unknown is. Okay, so this will actually work for me. Okay, the other way wouldn't, because I haven't really accounted for things correctly. Okay, I found 12%, so this is the old method. I essentially found 40% of that original and just added that in. But I actually have to find 40% of the increased amount in order for this to work. So let's go put this all into a formula. So our concentration of antifreeze, I'm just going to write AF for short, that's going to be equal to the volume of antifreeze in that solution divided by the total volume. Okay, so that's going to include both the water and the antifreeze. Now I want that concentration to be 40%, and we can write that as a decimal at 0.4. The volume of antifreeze inside, X, the total is going to be the initial amount of water plus the unknown amount that I'm adding. Okay. Now we can go ahead and try to solve this. So if you want, you can leave it as 0.4. You could change it to a fraction, 2/5. And this might actually be easier to do that cross multiplication bit. So to get rid of that fraction, cross multiply, or the cross product, or whatever you want to call it. Okay. And what that's going to do for you, you're going to have 12 plus x's plus 5, or not plus, sorry, that should be equals 5x. Okay, there we go. Distribute 24 plus 2x is equal to 5x's. Move your variables together, collect those like terms. 24 is going to be equal to 3x. Divide everything by 3. 8 is going to be equal to x. So in order for this solution to actually have the concentration we need to add, so it requires 8 liters of antifreeze. Okay, in order to get the concentration right, we have to make sure we add in 8 liters, because that's going to increase not only the amount of antifreeze inside, but the total volume. Okay, both things are going to change at the same time. Now again, that formula wasn't terribly difficult to solve, but the understanding behind it, that was hard. Okay, that's going to take the most amount of thinking. Okay, a couple more here. They are a little different. So if you flip it over, just the last two here. 2 consecutive even whole numbers are selected. The difference between the reciprocals of the 2 numbers is 1/60. Determine those 2 numbers. Now it's helpful to know what the word consecutive means. So this is going to be one after the next. Next. Okay, so they go, they follow a pattern. They go in order. So 1, 2, 3, 4, 5 would all be consecutive numbers. Now I also need them to be even. So 2, 4, 6, 8, those would all be even numbers. And they are all 2 apart from each other, all even numbers. So let's say we choose the number. So let's let the first number, let's let that be equal to x. And just think about this for a second. If I let it equal x, that number could be anything. Okay, it could be 2, it could be 4, it could be 6, it could be any even whole number, but there's nothing stopping this from being 1 or 3 or 5. Okay, those are all odd numbers. That inherently gives us a problem. So let's actually let that first number be anything you want, but doubled. As soon as you double something, it's going to become even. Okay, no matter what you choose. If you choose 3, you double it, you get 6 as your even number. Okay, so as long as you double it, this will be fine. Now for the second number, we need to let that be 2 more than the first one. Okay, so they've got to go in order. So my first one is 2x, the next one is 2x plus 2. You could do minus 2 also and go back the other way because you could subtract. But we want to keep them, let's keep them positive. It makes our life a little easier here. Okay, subtraction usually gives us an issue. Okay. So let's try this out here. We are told that the difference, so this is going to mean subtract. Reciprocal means essentially the flipped version. Okay, so the difference, so subtract the flip versions of those numbers, you get 1 over 60. So let's flip those numbers first to make our expression. So 1 over 2x minus 1 over 2x plus 2, that's going to be equal to 1 over 60. So what I'm really trying to locate here are those two numbers. So if I can solve for x, I can plug them back into my original expressions of 2x and 2x plus 2. I can find those two numbers. Okay, so let's go solve it. Now this time I've got three denominators to think about. So if I take the entire expression, multiply by all of those denominators, so 2x, 2x plus 2, and 60. Essentially, I'm going to take the whole thing and start distributing to each term. Okay, the resulting expressions won't have fractions anymore, but they're going to have different things attached to the top. So my 2x's for my first term, those are going to cancel. So we're going to be left with 2x plus 2 multiplied by 60. The second one, the 2x plus 2's cancel, and you're going to subtract 60 times 2x. And last, you're going to have a 2x and 2x plus 2 to worry about. Let's expand everything here, and then we can go ahead and start to simplify. So 120x plus 120 minus 120x, so that's nice, and terms will cancel, equals to 4x squared plus 4x. So at this point, cancel where you can, collect like terms, put everything on one side, make it equal to 0. So my 120x's will cancel, and we'll move the 120 to the other side at this point. So 0 equals 4x squared plus 4x minus 120. It's basically a quadratics question now, where you have to factor, take out a greatest common factor if you can first. Looks like we can take out 4. So 0 equals 4 x squared plus x minus 30. Okay, so this is the expression we're going to go factor. Now, if you do factor it using your sum and product rules, you're going to get x plus 6, x minus 5. Your two numbers become, so x could either be -6 or x could be 5. Okay, now those aren't our final answers, because remember how we actually define our numbers. To start with, we define them as 2x and 2x plus 2. So what we actually need to do here is take the two answers we got for x and actually substitute them back into the top. Okay, that'll actually tell us what our numbers are. And there's a couple things that we got to think about when we do that. So let's start plugging things in. So let's do two cases. If x equals 6, that's -6. If x equals -6, or if x equals to 5. Okay, and we'll start plugging things in. Okay, so if our first number is 2x, that means it's 2 times -6, which is -12. Okay, so 2x plus 2, 2 times -6, and 2 more. That's going to give us -10. Okay, we'll plug in the other ones for 5, and then we'll actually talk about them. So 2x means 2 times 5. That's going to be equal to 10. 2x plus 2. That's going to be 2 times 5 plus 2. That'll give me 12. Okay, so here's my two cases. I could either have -12, -10, or +10, +12. The same numbers. Now the question's very specific, and it says I have whole numbers. Okay, whole numbers don't include negatives. Okay, so these are no negatives. It's only your counting numbers, essentially. So 0, 1, 2, 3, 4, 5, all the way up. No negatives at all. So I can't actually use -6 here, because that's going to give me two consecutive even numbers, but they're negative, and I can't have that. So x equals 5 is the one number, the answer, the 0 from that quadratic equation, that's going to actually give me the two numbers I need. So 10 and 12 are both even, they're consecutive, so they're 2 away from each other, and they satisfy this condition. So therefore, the two numbers are 10 and 12. Okay, the other ones don't satisfy the condition. These are not whole numbers. Okay, so my two whole numbers are 10 and 12. Okay, one more here, and that takes care of our rational expression application. So the last one talks about a rectangular flower bed at a garden center. It's got an area of 144 meters squared. Now, during a redesign of the garden center, the dimensions of the rectangular flower bed are altered, but that area stays constant. Okay, that area stays the same. Okay, the width is doubled, the length is decreased by 12. Calculate the dimension of the redesigned bed. Okay, so let's draw a picture of originally what it would have looked like. It does say it's a rectangle, so let's draw a rectangular flower bed. Okay, that area was told to us. It was 144, I believe, meters squared. Now, they didn't really tell us what the dimensions were. So all we can say at this point is that if it's a rectangle, I've got a length and I've got a width. Okay, so this is going to be, let's say, original. Okay, that's the original one. Well, let's go draw the new one. Now, it said the dimensions were changed, but the area was the same. So when we draw this new one, let's assume it's still, I don't want it to be a square. Let's assume it's still a rectangle, but we just don't know the dimension. So you can turn it, draw a little different. The area would be the same, 144 meters squared, but they're telling us something specific about the length and the width. Okay, so they've told us that it will be the original length, but decreased by 12. So let's say this is length minus 12. Our width was getting doubled. Okay, so 2W. Now, in order to find the area of a rectangle, you can actually take the length, width, multiply them together. Now, we can do this for both of these. So length, width equals 144. And for the one down below, we could say length minus 12 times 2W, again, equals 144. Now, let's think about this for a second. I've got two different equations here. I've got two variables in them, and they are the same variables of length and width. This is a systems of equations problem. Okay, this is a Math 10 question. So what we're actually going to do here, let's solve this using substitution. So if I take the original one, it's a little easier to work with. If we solve for one of the variables, we'll plug it into the other one. So let's solve for, again, the choice here doesn't really matter, so let's solve for W. Let's solve for W. So let's divide both things by L. So the width is going to be equal to 144 divided by the length. Okay, and we're going to plug that into the one underneath. Okay, so we're going to say that the length minus 12 times 2 times the width, so that's 2 times 144 over length equals 144. Okay, let's simplify the set of brackets first. So length minus 12, the other one will be 288 over length. That's equal to 144. Okay, if we multiply, we'll distribute those two things. So the length will go to the other fraction. Lengths will cancel. I'm left with 288 minus whatever 288 times 12 is. It's 12. That'll be 3456. So minus 3456 divided by length. That's equal to 144. Okay. Let's get those constants together. So we'll subtract 288 from both sides. And keep in mind, this isn't the only way to do this. There are many others. This is just one that jumped out to me. Okay, so if you're not fond of that fraction, there is another way. Now 144 minus 288. Negative 144 is what we end up with. Okay, now this is going to be another one of those cross-multiply scenarios. So 1, we'll do a cross. So that means negative 3,456 is equal to negative 144 times the length. If you divide both sides by that 144, 3456 divided by 144, the negatives will cancel. 24 is going to be the length, okay, which is very, very helpful because now I know what the original length was. Since I know what the original area was also, I have a way of finding out what the original width was. Once I can do that, then I've got enough information to find the new dimensions. So since I know what that length is now, let's plug it back into the expression that we had for width. So the width is going to be equal to 144 divided by 24. That was our length. So my width, divide them, the width is 6, and that's meters. Okay, so those are going to be the old dimensions. Okay, a width of 6 meters, a length of 24 meters. If we go to do the new ones, whatever our width was, it was doubled, so 2w, that's going to be equal to 12 meters. The new length was length minus 12, so if I do 24 minus 12, that's going to give me 12 meters also. Okay, so my new flower bed is actually a square, 12 by 12. If you want to draw yourself another picture, here's the new one. It is a square as best I can draw it. There's a square. Okay, so 12 meters, 12 meters, and you know that 12 by 12, when you multiply them, you still get your 144. Okay, so it does work, works great. Okay, so again, it's that setup there which gives us our rational expression. So basically, since that variable is on the bottom, that length, the length can't be 0, or else I'm going to have a one-dimensional shape. If that length was non-existent, I'd have a flat shape. I wouldn't actually have a shape, to be honest. I wouldn't have a rectangle anymore. That dimension would disappear. Okay, so here, that length can't be equal to 0. That would be your non-permissible value. Okay, so there's your section on rational applications. You've got your homework ones underneath. Hopefully those ones go well for you. If you do need that assistance, please contact one of your teachers. They'll be more than happy to help you out.